In this program, we look at the reasons behind the introduction of a new air conditioning refrigerant for Volkswagen Audi vehicles and outline the implications for the workshop. Section 1 looks at the differences between the old and new refrigerants and their impact on the environment. Section 2 highlights the components which have been changed to accommodate the new refrigerant. Section 3 outlines the important working practices and explains how to use the VAG 1770 charging station to recover, evacuate and recharge the refrigerant circuit. The charging station, manufactured by Agramco, automatically recycles the recovered refrigerant.
Most of you will have already heard about chlorofluorocarbons, or CFCs as they're known, on the radio, television or in the press. The first chlorofluorocarbon with specific physical properties was developed at the end of the 1920s. It was primarily used in industry. However, since then, a number of other CFCs have been developed which are used in up to 5,000 different applications. Probably the most well-known use of CFC is as a refrigerant in the domestic refrigerator. Other than domestic use, there are many other examples of refrigeration applications. For instance, here and here. These are just a couple of examples. Considerably larger quantities of chlorofluorocarbons were required in the past for the manufacture of various foams. The greatest quantities of hard and insulating foams being used in the building industry for thermal insulation of factories and houses. Many of you are probably familiar with this particular example of expanding foam. Once again, it's CFC which has been used as the propellant and to increase the volume of plastic. Returning to refrigeration technology, the air conditioning systems of Volkswagen and Audi vehicles have, since the early 70s, enabled comfortable interior temperatures to be maintained. Here too, it's been a proven chlorofluorocarbon with the designation R12 that has up to now been used. However, in the light of today's findings, all CFCs have one thing in common. They disturb certain natural cycles and are therefore harmful to the environment. This was established indisputably by scientists working independently of each other in different fields round about the mid-80s. So why are CFCs so dangerous for the environment? At a height of 20 to 30 kilometres above the Earth in the stratosphere, the ozone layer surrounding our planet acts as a gigantic filter protecting us against the sun's ultraviolet radiation. Free CFCs, for instance those released incorrectly from an air conditioning system, rise towards this ozone layer. It can take many years before they reach there, but once there, they disintegrate and release chlorine. In a complex sequence of chemical reactions, this chlorine attacks the individual ozone molecules. As a result, the ozone layer becomes thinner. Due to the reduced filter effect of the depleted ozone layer, there is a higher concentration of ultraviolet radiation on Earth. This can disturb individual cycles, including the human immune system. The effects can cause an increase in eye disorders and skin cancers, for example. The greenhouse effect, on the other hand, is a completely different problem to that of the depletion of the ozone layer. Here, too, to a certain extent, chlorofluorocarbons are involved, intensifying a problem which is, in fact, a quite natural one. Certain natural trace gases in the atmosphere, which are produced by human beings, hinder the sun's rays, which reach the Earth's surface, from returning to the outer atmosphere. As a result, the temperature on the Earth's surface is increased. Other trace gases are produced in the course of everyday activities. In addition to CO2, that's carbon dioxide, which arises from the burning of wood, coal, oil and fuel, CFCs account for a large proportion of the ever-increasing concentration of trace gases, or greenhouse effect. Scientists today fear that the greater the concentration of trace gases, the more the Earth's average temperature will in the future rise. In view of the environmental problems which have been recognised, the leading industrial nations throughout the world have agreed to abandon the use of chlorofluorocarbons in the future. Legislation has already been passed in Germany to prohibit the refrigerant R12 being used in new passenger car air conditioning systems from the 1st of January 1995. And in England too, it will be a finable offence to intentionally release CFCs into the atmosphere. The new generation of air conditioners from Volkswagen and Audi already comply with this future legal requirement. As of model year 1993, they use only the refrigerant R134A, which is less harmful to the ozone layer.
In this section of the programme, we'll outline the main technical items and features which are specific to air conditioners filled with the R134A refrigerant. We'll use a Volkswagen Golf to illustrate some of the points. The workshop manual explains the repair and adjustment procedures, plus the main points concerning safety. Detailed advice on likely service complaints are to be found, as usual, in the fault-finding binder. Further details concerning the refrigerant circuit of air conditioners using the new R134A refrigerant are described in this workshop manual. But before we start to look at some of the technical points, here's a word of advice. Special tools and test equipment are required to open or work on the refrigerant circuit. So bear in mind that such operations should only ever be carried out by authorized dealerships or specialist air conditioner service centers. Now, let's look at the differences between the old and the new refrigerant. R12 is a CFC, a chlorofluorocarbon. R134A is a fluorocarbon. R134A is therefore a refrigerant without the chlorine, which is so harmful to the environment. Due to the changed chemical structure of the new refrigerant, it's been necessary to make a number of changes to the air conditioning components and supplement the service equipment. Under no circumstances should R12 be introduced into an air conditioning system designed for R134A, as all the materials and components are matched to the new refrigerant. These markings on the cylinders indicate the type of refrigerant. Freon denotes R12, and Suva, for example, implies R134A. Another point to note is the size of the threads on the hoses, Imperial on Volkswagens and metric on Audis. You'll also require this adapter to connect to the cylinder. Instead of mineral oil, a fully synthetic lubricant with this designation is used to provide lubrication for the compressor of R134A refrigerant circuits. A separate oil is available for commercial vehicles. The chemical structure and pressure characteristics of the new refrigerant are, as already mentioned, different to those of the old R12. For example, the average operating pressure in R134A circuits is greater by approximately 3 bar, and as R134A is a small molecule gas, it finds leaks more easily. Consequently, the plastics used for all hose lines have been specially selected with this in mind. The inner coating ensures even greater resistance to leaks. Green markings on all refrigerant hoses, and in addition a green band during the initial phase of introduction, indicates a system using R134A refrigerant. The materials used for these seals have also been newly developed and are manufactured for production use in black. However, should the new R134A system need repairing, replacement seals are coloured red for ease of identification. The compressor's bearings and seals are designed to meet the requirements of the slightly increased operating pressure. The new compressor can be recognised, as you might expect, by this green label. In the event of the radiator fan failing, it's possible for the pressure in the refrigerant circuit to become too high. In addition to the high pressure switch, which turns off the compressor at approximately 32 bar, a pressure relief valve protects the entire system from damage should the pressure exceed 40 bar. If the pressure is exceeded, a plastic disc is pushed out by the pressure relief valve, which lies directly underneath it. If this does occur, you would of course need to inspect thoroughly the air conditioning circuit. You're probably familiar with the round pipe type of condenser units. These have now been replaced by flat pipe condensers, which are more efficient. As you can see, they are considerably flatter. The new refrigerant, in conjunction with the synthetic oil, based on polyalkylene glycol, which has been matched to it, is more hygroscopic. In other words, it absorbs moisture more readily than the existing R12 refrigerant and mineral oil. This has been compensated for by both changing the quantity of the drying agent and the size of the container. The expansion valve has also been modified to adapt to the changed flow characteristics of the R134A refrigerant. Once again, this is marked with a green label. We begin this last section of the program by reminding you of some of the important safety measures you must be aware of when working with air conditioning systems. As we mentioned earlier, special tools and equipment are necessary to open or work on the refrigerant circuit. As refrigerant escaping or released from the system has a temperature of approximately -26 degrees centigrade, you should always wear protective gloves and safety goggles when working on the system. An eye wash should also be at hand. Refrigerants are colourless and odourless. As they are heavier than air, they displace oxygen. You should therefore only ever work on an air conditioning refrigerant circuit in rooms with good ventilation, and never in an inspection pit. Ignoring these basic rules could lead to the risk of asphyxiation, a danger which is undetectable. Temperatures above 80 degrees centigrade lead to chemical breakdown of the refrigerant, so avoid soldering or welding on either the air conditioning system or in the immediate vicinity. Volkswagen and Audi air conditioning systems are maintenance-free. However, as part of the annual inspection service, it is a requirement to interrogate the fault memories of all electronically controlled systems. This, naturally, should include the air conditioners, and is therefore the only service requirement. Audi models can be interrogated using the VAG 1551, while Volkswagens must be interrogated via the air conditioner's control panel. Nevertheless, if a customer complains of inadequate cooling, further investigation will be necessary. One possible cause could be a loss of refrigerant due to a minor leak. Using the new leak detector, or sniffer, you can detect even the smallest leak in either R12 or R134A circuits. The new service equipment, VAG 1770, is designed to recover, evacuate and fill the refrigerant circuit. A new feature is that the refrigerant is automatically recycled. That means dried, cleaned of particles, and then refilled into the circuit once any repairs have been completed. A point to remember, though, is that if the refrigerant has been contaminated by, for instance, mechanical damage of the compressor, it should not be recycled. This is because, firstly, it could cause undue dirtying of the filter units, and secondly, there is the possibility of chemical breakdown of the refrigerant. This could be as a result of high temperatures occurring during the breakup of the compressor. Let's now look at how to recover, evacuate and refill the R134A air conditioning system of this Volkswagen Passat using the VAG 1770 charging station. Before using the unit, check the level of the compressor oil. It should be between these marks. The refrigerant sight glass, which is on the opposite side of the machine, should also be checked for level. Occasionally it may have a slightly milky look, but this is quite normal and is nothing to be concerned about. Moreover, you'll need to check the quantity of refrigerant in the charging cylinder and mark its level with the O-ring. This enables you to determine the quantity of refrigerant recovered from the vehicle's system. To avoid either running out of refrigerant when refilling the system or having too much when recovering it, there should normally be around 1,000 to 1,500 grams in the charging cylinder. To make sure that there isn't any refrigerant oil left in the machine from a previous operation, open this valve and drain off any oil. Once drained, close the valve, empty and clean the beaker if necessary, and replace it under the tap. Now ensure that both control valves are completely closed by turning them fully clockwise, but don't over-tighten them. Connect the blue hose to the low-pressure side of the vehicle's system. That's the smaller of the two connectors. And open the valve by turning it clockwise. Next, connect the red hose to the high-pressure side of the circuit and open its valve. Incidentally, if the vehicle has only one connector, which many of the new Audi vehicles do, then you need only connect the red hose. Irrespective of whether the vehicle is fitted with one or two hose connections, the procedure for using the VAG 1770 is exactly the same. The first step is to find out whether there is refrigerant in the car's system. Turn the function switch to the test position and turn on the mains switch. At this point, the ready lamp should light. The readings on both the low and high pressure gauges should indicate the same pressure, approximately 4 to 5 bar. If the gauges don't record a pressure, then it suggests that, for whatever reason, the vehicle's refrigerant circuit is empty. Rotate the function switch to the recovery position and turn the control valve nearest to the blue hose in the recovery direction. The lamp will light to indicate that recovery is taking place. Allow the unit to run until the lamp goes out. You then need to wait for about 5 minutes, as the lamp may come back on again if any refrigerant has been temporarily trapped in the system. If the lamp does light, wait a further 5 minutes for the recovery cycle to be completed. Check the quantity of refrigerant recovered by noting how much the level in the charging cylinder has risen. By the way, if the recovery lamp doesn't light during the recovery procedure, it indicates that the vehicle's system was empty. However, this should have already been established during the initial test phase. During the recovery cycle, a quantity of refrigerant oil is drawn off together with the refrigerant. The exact quantity of oil must be determined so that the same amount can be replaced. Open the drain valve and collect the oil in the beaker. Don't forget to close the valve afterwards. Measure the quantity of oil, as this amount will have to be refilled into the system later. Having emptied the system, the next operation is to evacuate it. Evacuation removes moisture from the circuit, including the dryer unit, and creates a depression to facilitate refilling. The control valve, next to the blue hose connection, must be closed, and the function switch turned to the evacuation position. Now watch the vacuum gauge. Once it reaches 0, or within 1 to 2 divisions of it, leave the unit running for about a further 30 minutes. When the time has elapsed, press the vacuum check button to interrupt the evacuation process. If the system is completely evacuated, the vacuum gauge's needle should not rise more than 1 division. If the needle does rise, say 2 or 3 divisions, and then remains at that point, it suggests that there is still some moisture left in the system. In these instances, press the button again to continue the evacuation for a further 15 minutes, and then repeat the test. If, on the other hand, the needle rises more than 1 division and continues to rise, it suggests that there is a leak in the refrigerant circuit, which must be checked carefully and repaired. This can be done by adding a small quantity of refrigerant to the circuit and then using the leak detector to locate the problem. Once you're certain that there aren't any leaks, you're ready to replace the refrigerant oil. Close the valve on the high-pressure coupling and disconnect the hose. The oil syringe is then filled with PAG refrigerant oil directly from the container. Fill the syringe with the same quantity of oil that was removed during the recovery cycle. As the oil is hygroscopic, don't forget to reseal the container immediately after use. Push the syringe into the high-pressure coupling and slowly open the valve. The vacuum present within the refrigerant system will allow the oil to flow in freely. Once the syringe is empty, close the valve, remove the syringe, and wait for 1 or 2 minutes to allow the oil to disperse. The high-pressure hose can next be refitted and the coupling's valve fully opened. By the way, if you're replacing the compressor, the filling procedure is a little different. You must first determine the quantity of oil required by referring to the air conditioner manual. The oil is then poured directly into the compressor immediately before it's fitted. Before charging the system, check how much refrigerant is required for the vehicle. You'll normally find a label indicating the system's capacity under the bonnet. For example, this Passat requires 1150 to 1200 grams of refrigerant. To this figure, you must then add an extra 100 grams to allow for the filling of the hoses, making a total of 1250 to 1300 grams. The O-ring is then used to mark the level to which the charging cylinder must be drained to ensure the correct quantity of refrigerant is refilled into the system. We are now ready to recharge the system. Turn the function switch to the charging position and open the control valve which is adjacent to the red hose. The level in the charging cylinder will now fall as the R134A enters the system. Closely watch the level and close the valve when it reaches the point previously marked by the O-ring. The function switch is then turned to the test position. The air conditioner is now ready to be tested. Start the engine and switch it on to the coldest setting. Leave the engine and the air conditioner running for approximately 5 minutes to make sure that the car's interior is being cooled. Increase the engine revs to roughly 2000 and watch both pressure gauges. If the system is working correctly, the high pressure gauge should rise to between approximately 10 and 14 bar. Simultaneously, the low pressure gauge should fall to between 4 and 1 bar. Assuming the system is working correctly, the hoses can next be removed. Close the valves on both hose couplings and disconnect them from the vehicle. Don't forget to refit the protective dust caps. To reduce the risk of damage occurring to the vacuum gauge, the refrigerant contained in the hoses should be recovered. Return the function switch to the recovery position and open the control valve, which is adjacent to the blue hose. Once again, the lamp will light. When the lamp goes out, close the control valve, turn off the main switch, and return the function switch to the test position. To return the vacuum gauge to its rest position, follow carefully this procedure. Remove both hoses. Turn the function switch to evacuate and turn on the main switch. Next, press the vacuum check button. This allows the gauge to return to its rest position. Finally, turn the main switch to off, return the function switch to test, and press the vacuum check button once again. The equipment is now set back to its start position. After completing any work on the system, don't forget to thoroughly check the system for leaks with the detector. In the event of a leak being detected, follow the recovery procedure and then repair the fault. It will be necessary to once again completely evacuate and recharge the system, not forgetting, of course, to replenish the quantity of lost oil. During the program, we've described the most significant differences between the old R12 refrigerant and the new R134A, and, equally importantly, the reasons for its introduction. We've also highlighted the components which, by necessity, have been redesigned to accommodate the R134A. Furthermore, we've demonstrated how to recover, evacuate and recharge a refrigerant system using the VAG 1770. We appreciate that working on an air conditioning system is probably something that you don't do too often, but we hope that by viewing this tape before working on an R134A system, it will help to make your job a little easier.